Hey there, science fans! Let's talk metals. What are they? They're like the superheroes of the periodic table with amazing powers. Metals are shiny, strong, and can be molded into different shapes.
Metals are found all over the periodic table. See those elements on the left side and in the middle? Most of them are metals. We use them for everything from building skyscrapers to making tiny computer chips.
Metals are really important in our daily lives. Think about it. Your bike, your phone, even the pots and pans in your kitchen, all thanks to metals. So next time you see something shiny and strong, remember, it could be a metal in disguise. Metals are known for their awesome properties. One of the coolest things about them is that they're malleable. That means you can hammer them into thin sheets like aluminum foil.
Metals are also ductile. You can stretch them into wires like the copper wires that bring electricity to your home. Amazing, right? And don't forget about their conductivity.
Metals are excellent conductors of heat and electricity. That's why we use them in things like cooking pots and electrical wiring. Metals are usually solid at room temperature, except for mercury, which is a liquid. They're strong and durable, which is why we use them to build bridges and buildings. But hold on, not all metals are created equal. Some metals are soft like sodium, which you can cut with a knife.
And then there's mercury, the rebel of the metal world. It's a liquid at room temperature and is used in thermometers. Mercury is considered a metal despite being in liquid form at room temperature because it possesses the fundamental characteristics of metals. Here are some key reasons. Atomic structure. Mercury has a metallic atomic structure with free electrons in its outer shell, similar to other metals. Conductivity. Mercury is an excellent conductor of electricity and heat, just like other metals. Luster. Mercury has a shiny metallic luster when in liquid form. Ductility and malleability. In its solid state at very low temperatures, mercury can be drawn into wires, ductile, and hammered into sheets, malleable. Chemical properties. Mercury forms alloys called amalgams with many other metals and reacts with non-metals in a similar manner to other metals. The liquid state of mercury at room temperature is due to its unique electron configuration, which leads to weak intermolecular forces and a low melting point. However, this doesn't change its classification as a metal because its fundamental properties align with those of metals.
Even though there are exceptions, these special cases help us understand the diversity of the periodic table. Keep those science brains working. Section 4. Non-metals, the other side of the coin. Now, let's meet the non-metals. These elements are like the opposite of metals. They're not shiny, they're usually brittle, and they don't conduct heat or electricity very well.
Think about wood, plastic, or glass. Those are all made with non-metals. They're still super important though.
We need oxygen to breathe, and carbon is the basis of all life. Non-metals can be solids, liquids, or gases at room temperature. They're different from metals in many ways, but they're just as important in the world around us. And what about exceptions? Bromine is a non-metal that is found in a liquid state at room temperature, similar to how mercury is a liquid metal. Section 5. Metals versus non-metals, a tale of two elements. So how can you tell metals and non-metals apart? Think about their properties.
Metals are usually shiny, malleable, and good conductors. Non-metals are the opposite, usually dull, brittle, and poor conductors. But are there any commonalities between metals and non-metals? Yes, both can form compounds. For example, carbon, a non-metal, and iron, a metal, can combine to form steel.
But remember, there are always exceptions in science. Some metals are liquid and some non-metals can be shiny. That's what makes chemistry so interesting.
By understanding the properties of metals and non-metals, we can use them to create amazing things. From the phones in our pockets to the medicines we take, chemistry is everywhere.
So keep asking questions, keep exploring, and stay curious.